Good morning, students. So we will start the next topic of chapter 5, derivative and differentiability. So what is derivative? Derivative is rate of change in y. Y can be the function of x with respect to change in x. So rate of change in y, which can be put in symbolic form like this. Rate of change in fx. Change in fx means fx minus fa, and change in x is x minus a, and rate means divide both. As x approaches to a means the change is very small. So this is the definition of a derivative at a point. We have written here f dash a, or dy upon dx at x is equal to a. This is the derivative of fx at a. So if this limit exists, then it is called differentiable, and if it does not exist, then it is called not differentiable. So differentiability means whether the derivative exists or not, whether the derivative is defined or not. So this is called the differentiability of a function. So how to check? Just we need to find this limit from left hand side and right hand side, because limit of a function exists only if both left hand and right hand limit exist and are equal. So here also function fx is differentiable at x is equal to a if left hand derivative and right hand derivative of fx at a point a are equal, where left hand derivative means the derivative where x approaches to a from left hand side, because derivative means rate of change, so all the other things remain same. So similarly, right hand derivative means limit x approaches to a from right hand side, fx minus fa upon x minus a. So if both these limits are equal and exist, then we call function is differentiable. Or we can also write this like h approaches to 0, f x plus h minus fx upon h is equal to limit h approaches to 0, f x plus h minus fx upon h, where h negative, h approaches to 0 minus, and positive left hand derivative and right hand derivative. If both these things are equal, then we call function as differentiable. So we now will check one example, that a function may be continuous but it is not necessarily differentiable. So let us take the example of fx is equal to mod x, and we have to check that this function is continuous at x is equal to 0 but not differentiable at x is equal to 0. So for continuity, first of all we give here the heading that we are using the concept of continuity. We are checking continuity at x is equal to 0 of this function. So how we check continuity? We find left hand limit and right hand limit and value of the function at 0. If these three things are equal, then we call the function as continuous. So what is left hand limit? Left hand limit when x approaches to 0 from left hand side. Or what is the function? Function is mod x. Similarly, right hand limit means x approaches to 0 from right hand side, function is mod x, and value of function means when we put x is equal to 0 in the function. So what is this limit? If we take x from left hand side of 0, if this is here somewhere, x is here, that means x is less than 0, x is negative. If x is negative, then the mod sign will make it positive. Or another thing is also that the definition of mod x is equal to x if x is positive, and it is minus x if x is negative. So we can use it here. If x is on the left hand side of 0, means x is negative, then its value will be minus x, right? And x approaches to 0 means minus 0 is 0. And similarly, if x is on the right hand side of 0, means x is positive. If x is positive, then mod of x is nothing but x. So limit of x as x is 0 is 0, and mod of 0 is also 0. All the three things are 0. That means left hand limit, right hand limit, and value of the function are equal. Therefore, fx is continuous at x is equal to 0. Now we need to check the differentiability. Now we give the heading here, differentiability. So differentiability at x is equal to 0. So differentiability means left hand derivative. We have to find right hand derivative, and we have to check whether both are equal or not. According to that, we can define the differentiability of this function. So what is left hand derivative? It is x approaches to 0 from left hand side, fx minus f0, that is the definition, x minus 0, because in place of a, here we have 0 at which we have to check the derivative. And similarly, right hand derivative, x approaches to 0 plus means x is approaching towards 0 from right hand side, and other values are same. So what is this? Fx is mod x, f0 is 0, we have already seen it, x minus 0 is x, and limit x approaches to 0 minus. So again we can see that x is on the left hand side of 0, means x is less than 0. If x is less than 0, mod of x is minus x. So we can put here minus x. It is minus x, minus 0 is nothing, upon x, limit x approaches to 0. X is cancelled with x, we get minus 1 as this limit. On the other hand, right hand side, we have 0 plus, x approaches to 0 from right hand side. If x is on the right hand side, means x is greater than 0. If x is greater than 0, then mod of x is x. So we can put here x, the value of this. First of all, we put fx as mod of x. This is 0 and denominator is x, and limit x approaches to 0 plus. Now we can put mod of x as x because x is positive. So mod of x is nothing but x. X upon x, and limit x approaches to 0 plus. X cancelled with x, we get 1. So what we get? Left hand derivative not equal to right hand derivative. Both these are not equal. Therefore, fx is not differentiable at x is equal to 0. So continuity does not imply differentiability. A function can be continuous, but it cannot be differentiable always. So revise this. Thank you.